All right, today we're going to dig deep, and I mean really deep, into one of the biggest and, let's be honest, most controversial energy resources on the entire planet, the Alberta Oil Sands. It's a massive story, full of incredible science, huge economics, and some really big questions about where we're all heading.
You know, when you picture oil, you probably think of that black liquid gold gushing out of the ground, right? But what if I told you one of the largest oil deposits in the world looks nothing like that?
Because that's exactly what we're talking about with the oil sands. It's this huge deposit of oil, but it's locked up tight in a mix of sand, clay, and water. So how in the world did it get there? And what does it actually mean for our energy supply? Let's get into it.
Okay, so first things first. To really get a handle on the oil sands, you have to understand the absolutely incredible scale of this thing and just how important it is to Canada's economy. The number you see here, it's just staggering. We're talking about 161 billion barrels of oil that are recoverable with the technology we have right now. It is an almost unimaginable amount of energy buried under the Canadian wilderness. And to put that number into perspective, that officially makes Canada's oil sands the third largest proven oil reserve in the entire world. Yeah, that puts Canada in the same league as energy heavyweights like Venezuela and Saudi Arabia. And a resource that massive, well, it translates directly into some serious economic firepower. Over the years, this industry has pumped literally trillions of dollars into Canada's GDP. We're talking billions in government revenues that help pay for things like hospitals and roads, and it supports hundreds of thousands of jobs, not just in Alberta, but in businesses from coast to coast. So what exactly is this stuff? This thick, oily gunk at the heart of the whole operation? Well, let's take a closer look at what they call bitumen. So, bitumen is basically what's left over from a really old geological process. Think about it like this. Millions of years ago, when Western Canada was covered by a sea, there were tiny microbes that basically ate all the lighter, easy-to-digest parts of the crude oil, and this heavy, super complex hydrocarbon is what they left behind. And this chart right here, this really shows you the central challenge of the oil sands. I mean, look at it. When you dig up a scoop of this stuff, a whopping 80% of it is just plain old sand and clay. The valuable part, the actual oil, the bitumen, is just that little 10% sliver.
Now, the reason bitumen is so tricky to work with is because of these things called asphaltenes. They make it incredibly thick and sticky. So thick, in fact, that at room temperature, it's pretty much a solid. Think of it like cold molasses or the tar they use to pave roads. It just does not flow.
So, if it doesn't flow, how on earth do you get it out of the ground and turn it into something you can actually put in your car? Well, that's where some truly incredible engineering comes into play. This is the fundamental puzzle, right? The big technological hurdle that the entire industry had to figure out. And it turns out the answer completely depends on how deep underground the bitumen is. Basically, there are two main ways to do it. For the huge majority of the oil sands, about 80% of it that's buried way too deep to dig, companies use what's called in situ, which just means in place. For the other 20% that's closer to the surface, they use more traditional, but massive, open-pit mining. The in-situ method is actually pretty genius. They drill down and pump super hot, high-pressure steam deep into the ground. That steam heats up the bitumen, making it thin enough to actually flow. Then, they just pump the mixture of bitumen and hot water back up to the surface, separate them, and reuse the water. Mining, on the other hand, is a bit more straightforward. But the scale is just colossal. We're talking about some of the biggest trucks in the world hauling the oil sand to a plant. There, it gets crushed up, mixed with hot water to create this kind of slurry, and that allows the lighter bitumen to froth up to the top and get skimmed off. Okay, so getting the bitumen out of the sand is really only half the battle, because in its raw state, it's just too heavy and full of impurities for most regular oil refineries. It needs to be upgraded.
Think of an upgrader as kind of like a pre-refinery. It takes that raw bitumen and heats it to incredibly high temperatures. This literally cracks those long, heavy hydrocarbon molecules into smaller, lighter, and more valuable ones. Then, after they clean out stuff like sulfur, they blend everything together to create what's called synthetic crude oil, a really high-quality product that's now ready for a normal refinery.
So once you've got either that synthetic crude or diluted bitumen, you run into the next big challenge. How do you get it from northern Alberta to customers who are thousands of miles away?
And that journey pretty much relies entirely on a massive, sprawling network of pipelines. As you can see here, That network basically acts like a giant funnel, and it directs almost all of Canada's oil south, right into the United States, especially to those big, specialized refineries in the Midwest and down on the Gulf Coast.
And this whole setup creates a really interesting economic situation. I mean, think about it. In Alberta, you have a massive supply of this heavy oil, but not a lot of refineries that can process it. Meanwhile, down on the U.S. Gulf Coast, the refineries are literally built to handle this exact kind of crude, and they want more of it. It's a classic case of supply and demand that often means Canadian oil gets sold at a discount compared to other global benchmarks.
Finally, you absolutely cannot talk about the oil sands without tackling the very significant environmental side of the equation.
So back in 2019, the oil sands industry was responsible for about 84 megatons of CO2 equivalent emissions. To put that in perspective, that was roughly 15% of Canada's total emissions for the entire year.
Now, most of those emissions don't actually come from burning the final product, like gasoline. They come from all the energy it takes to get the bitumen out and process it in the first place, mostly from burning natural gas to make all that steam for in situ or to power the massive trucks and heaters for mining. But, and this is a really key piece of context, thanks to new technologies, the most efficient oil sands operations today actually have emissions that are pretty comparable to the average barrel of oil refined in the US.
And all of this brings us to the big final question. As the whole world pushes for cleaner energy, and with Canada itself committed to getting to net zero emissions by 2050, what is the future for this immense resource? The truth is, its future hangs in the balance. It's become this high-stakes race between economic reality and environmental responsibility. And the path that's chosen from here won't just define an industry, it's going to define an entire nation's energy future.